close all of these links because it's a new class. This class is not as packed because I think a bunch of people moved to the 9 o'clock class. Now that one has a wait list. It is exactly 10:30, so I'm going to get started with this class. And I'll start with your very first homework assignment, which is also a very important homework assignment because it sets up the infrastructure for all of the homework assignments for this class. The first thing you want to do is to install Libreoffice. If you have not installed Libreoffice already, that's the tool that we'll be using in order to do homework assignments. To install Libreoffice, there are two options, and you can choose one of the two or both, okay, depending on how you are planning to do homework assignments for this class. If you have a laptop computer that you carry with you all the time and you're going to use that computer to do all of your homework assignment, you can just go to libreoffice.org and install Libreoffice on that computer permanently, and that works. The only problem with this approach using the LibreOffice.org installer is the application is only installed on that one single computer. Okay, if you want to use another computer to do your homework, then you have to install LibreOffice again on the other computer and also do the configuration and whatnot. So that means if your plan is to use multiple computers to do your homework assignment, this may not be the best option for you. Okay, you can still do it. Okay, nothing says you should not do this because LibreOffice is free. It doesn't cost you a penny. It only costs you about some disk space. I think it's only hundreds of megabytes. So by today's standard, it's not that much. Okay, it's not like CS6 where it will take up gigabytes to install. So the second option is to go to portableapps.com and install Libreoffice Portable. Now this is an interesting option because what it does is you can install LibreOffice using this installer to a thumb drive or an external hard drive. Okay, and the best part of this is you can plug in your thumb drive to any Windows system and be able to run LibreOffice from your thumb drive to do the homework assignments for this class. So if your intention is, well, I might use my home computer to do my homework, but when I'm at work, I might use my work computer during the breaks, to do my homework. And when I'm on campus, I might use computers on campus to do my homework too. This may be the best option. Yep.
Have you tried it on the library computers?
I have not, but I have no reason to think that it should.
You run stuff.
Oh, they don't let you run stuff?
Yeah, so if it's like a PC or something,
Well, if that is the case, you can always go to room 152 because that is the BCS lab. So if you're taking a class in any classes in BCS, business and computer science, you can use those computers in room 152.
Okay.
So that would be my recommendation, is to use those computers instead of the ones in the library. Okay, but thanks for letting me know.
Yeah.
So this is another option, and I think if you want to work on multiple computers and make sure that you have the same installation on all of those computers, this would be the best option. Are there any questions about portable apps? Why this is an option that some people should consider? Any questions? It will take up to 333 megabytes once it is installed on the thumb drive. I think by today's standard, it's not too bad. It's 1/3 of a gigabyte. But it will take a long time to install, I can tell you that much. Yep.
Will it have effect if different computers have different versions of Windows?
It should still work. Okay. I think as long as it is Windows XP or even 2000 or later, it should work. Yep. Does anyone use Windows 98? Because it may not work in Windows 98 or ME. Okay. All right, so that's step one. Step one is to install LibreOffice, and you can choose to install one or the other or both. The second one is important because I want you to customize LibreOffice. So maybe I would just go ahead and install it here onto my external hard drive, and then I can show you exactly what you need to do. It's going to spend some time to download, so I'm going to skip that part for now and talk about what you need to do once you have LibreOffice installed. Run LibreOffice, and when you are in LibreOffice, you want to go to the Tools, Options, and then User Data in LibreOffice. Okay, let me close this document first because it's done. And so what you want to do is to start LibreOffice. Okay, I'm just going to wait a little bit because I want to install LibreOffice Portable this time, and then show you what to do when you have LibreOffice Portable. And while we are waiting, not for much longer, we can also go to LibreOffice Portable here, and instead of looking at this page, I started to download already, so I don't need to stay on this page. You can go to the home page of portableapps.com. It shows you what type of other programs are also available in the portable format, so you can install that on your USB thumb drive. And you can see the icons here, and you already know what type of apps we are talking about. We have Firefox, we have Thunderbird, Chrome, Skype, LibreOffice, Dropbox, and etc., etc. So the question now is, well, why would I want to install Firefox on the thumb drive? If I have Firefox installed on the computer already, why would I want to install it on the thumb drive?
You've got some sort of proxy settings set up.
Okay. You want to keep the settings with you no matter where you go. Yep.
In case you have bookmarks that you want to use elsewhere?
Yep. Bookmarks, add-ons, plugins, and so on and so forth. If you have a portable app installation, all of that stuff is on the thumb drive. So no matter where you go, as long as you start it up from the thumb drive, all of those settings, plugins, add-ons, will remain the same as you configure it. Okay. So now that we have it already downloaded, I'm going to run the installer. This computer is really slow today because I'm not running Linux anymore. I'm not kidding. I mean, it really is much slower when I'm not running Linux. All right, so I'm going to run the installer and go through this process. Okay, this is the most important part. If you're installing the portable version, there's no reason to install it onto your C drive because the whole idea is to install it on a portable hard drive or a USB stick. So you definitely want to do this part and make sure you point it to the external hard drive that you want to install it to. So in this case, I can install it to my F drive or my G drive. So I'm going to install it to my F drive here. Click OK, and click Install. Now, you look at the progress bar, it's not really zipping really fast, but this is actually really fast already by comparison. If you try to do this on a USB stick, some of you may not even see any movement in minutes. Okay, it might take up to an hour to install the entire thing because it's writing all that stuff onto your USB stick, and some of the USB sticks have a very slow write speed, and that's why this process can take a lot longer than what you see here when I'm using an external hard drive. Okay, any questions about this part? So anyway, I'm going to leave the installer to continue the installation, but I will go to the permanent version of LibreOffice already installed on this computer and show you what you need to do. So you go to LibreOffice. OpenOffice will work as well. So if you already have OpenOffice, that's going to be okay. So you can use any of these applications, doesn't matter which one. So I'm just going to use LibreOffice without specifying an application. It starts right up. You go to Tools, you go to Options, and the first one under LibreOffice is the one that you need to specify, I just need you to write down your first name and your last name. And then you click OK. And at this point, this particular installation of LibreOffice using my account on this Windows box is already customized using my name. That's step 2. Are there any questions about step 2? Okay. So after step 2, you move on to step 3. In step 3, it's the actual homework assignment. The actual homework assignment works like this. You right-click, on this hyperlink here, and you click Save Link As, or depending on your browser, it may be Save File As, and so on and so forth. But the whole idea is you are going to save the file. You can save the file to the default, downloads folder. Depending on how you set up your browser, it may or may not even let you select where you're going to save the file. But in this case, it is letting me select where I'm saving the file. Because I already have a file of the same name, that's why we see the parentheses 1 here. So I'm going to say, we'll just say LibreOffice 1. Doesn't matter how you name the file. Okay, once you save the file, you can open it. Now, depending on whether you have Microsoft Office already installed on the computer, I would not click this tab here. Okay, if you're using Chrome, because if I click this tab here, because Microsoft Office is already installed, Microsoft Office is telling Windows that anything with an extension of ODS, it wants to use Microsoft Office to open it too. So do not use Microsoft Office for documents in this class. Okay, only use LibreOffice. So I can show you exactly what happens. If I click it, it's going to open up the document. Now, how do I know this is not LibreOffice?
This is
Because it says Excel, right? So, in case you open it accidentally using Microsoft Office, come on, show me. Okay, it's okay. Don't save anything. Just exit out of it. Okay, it's okay as long as you don't save it. Nothing is going to be changed. So what are we going to do if Microsoft Office is already installed and you don't want to change the association of extension to the applications? Open it inside LibreOffice. So what you do is you go to LibreOffice. Let me see.
Can you open with?
Hmm?
Can you just use open with?
You can also use open with. Yep.
Yeah.
Now I have a LibreOffice Portable installed already, so it's a good time to kind of switch gear a little bit and kind of talk about how to start LibreOffice from the thumb drive. Yep.
Are these instructions visible to us?
It is being recorded right now, so it will be a part of today's lecture recording on YouTube. Yep.
It's pretty easy.
So I go to the F drive. I have LibreOffice installed on my F drive. It's right here. So you double click on the folder, and now you have all of these executables that you can double click. To open a document, you can just use, you don't have to specify which application. So I am starting up LibreOffice Portable this time, and I can select File, Open, and then go to the Downloads folder, pick up the file that I downloaded a little bit earlier, click Open, and now we have the document open. So are there any questions about using the portable version of LibreOffice? But I really should not do anything at this point because the customization or the inclusion of my name was only done to the permanently installed version of LibreOffice. I haven't done that to the portable version just yet. So that would be the first thing I do, is to make sure that my name is the author's name. So once again, I go to Tools, I go to Options, make sure it's User Data, and type in my name. Yep.
What if you go by a different name? You can. What if you go by a different name than your actual name?
As long as I can still tell it is you, it's going to be okay.
You put like parentheses in.
Yeah, you can do that if
Okay.
you want to. Yep. Okay, now I can actually use column B to type in the answer to these questions. So I'm hoping that everybody in this class can answer these questions. What is your first name? Now when I say your, it means you, not me, right? So tag Young and student ID. Okay. Now would not be a good time to turn in the file because I have not saved the content yet. Okay. So the first thing you want to do before you turn it in is make sure you save the file. I would even go as far as closing the document first, just to make sure that everything is finalized, with that file that is already in the system. Okay. Now that everything is done, you can finish up the last step here. Since I did not log in as a student, I don't really have the option to turn it in. But when you log in as a student, after you complete the syllabus acknowledgement, you will see an interface down here that allows you to turn in the file as a submission. Any questions?
So there'll be a, what is it called? It's called when you turn it in, or will it be perfectly visible?
There should be a link. Let me see if I can set up my other account as a student first. Okay, so that way I can finish the entire demonstration as a student. So I'm using a different browser because I use one browser to log in as the teacher, and then I use the other browser to log in as a student. So this way you can see what you should see as a student. And I'm going to self-enroll in the class. Okay, so for those of you who are not in Moodle yet because you're on waitlist, you can go through the same process to self-enroll in Moodle. But make sure you self-enroll in the right section. It is the 1030 section here. I click it. It will ask me for a password. The password is P300, P300. And you can see if I unmask it, it shows P300.
Is it capitalized or lowercase?
Yes, lowercase. And then I click submit. Incorrect access password.
Maybe it's uppercase.
Yeah.
Is it uppercase? No, let's see. Well, I can always go back to the other one and change it. Nope, I forgot. Okay, let's see. We'll go to course administration and go to users, enrollment methods. See what password I used for this class. Okay, self-enrollment. No wonder nobody could self-enroll. Unmask. It's P300.
Well,
That's interesting.
And it's the right. Oh, this is the wrong class. Never mind. This page. I'm sorry, I forgot to change the link to this class first. Okay, there we go. Settings. Okay, somebody self-enrolled. And the password is P300. It should be P300. Okay, why would it not let me do it? Go to Firefox. Oh, it's not. I didn't read self-enrollment is down here.
What's the top
So,
one?
It's a guest access. I did not turn on guest access.
explains what it is.
That explains it. It's me, the professor, not reading instructions.
While reading.
It's a demonstration of how important it is to read instructions.
Attention to detail.
Yeah, attention to details. All right, so now that I enroll in myself as a student, I can finish up all the activities that you need to do too. So the first thing you need to do is to acknowledge the syllabus. So I'm just gonna do it real quick here. Submit all and finish. And I should get a score of exactly 1 out of 1 because that's the expected answer. Now I can go to topic 1, and the assignment does not show up. And I know exactly why too. Because I just went through this with my other class a little bit earlier. Now it's really embarrassing. I'll show you guys exactly why it is embarrassing. Why none of you can see it right now? Okay, if I go to the settings of the homework assignment, I go to where is it? Common module setting. I hit it before the semester, so I have to turn it back on again. Now, if I go back to Firefox, because this is my student account, so I can refresh this. And we have the homework assignment. So the question is, how do we turn in the homework assignment? So assuming you guys have acknowledged the syllabus, you can now do this homework assignment. When it's time to turn in, you click Add Submission, which allows you to turn in the file. So you just have to, you can either drag or drop the file from your file manager, or you can just click it and select Upload the file. Go to Browse, go to your Downloads folder, Downloads right there, and then select the right file to upload. There you go. And then we are not done yet. Click Upload this file. Some people stop right here and say, "Oh, I selected the file." Well, you might have selected the right file, but it has not been uploaded. It is now uploaded. We are not done yet. There's one more step to go. Remember to save changes. Okay. So after save changes, you will see the next screen. It's a confirmation that you have just turned it in. So if you see file submission and it has a link to the document that you just uploaded, that means I will have access to that document as well when it's time to grade it. So are we doing okay so far, about how to turn in your homework assignment?
Yeah.
Okay. What if you turn in your homework assignment and then you suddenly you remember, oops, I used Microsoft Office to edit the file. Well, it's okay as long as it's before the due date. You can always turn it in again. So the way you turn it in again is go to Edit Submission, click Edit Submission. Now, because you can only upload one file at a time, so what you need to do is you have to remove the file that you have turned in already, delete it. This is only deleting the copy on the server. So if you have it on your own hard drive, that version is not affected at all. So now that you have no file in this area, you can upload it again with the correct version. Okay. Now Moodle can only keep track of one file per submission because that's the way I set it up. So that means if you overwrite it with the wrong file, I would not be able to access the original file. So you got to make sure that by the time it is due, you have the right file uploaded to Moodle. Are there any questions about this part of turning in your homework assignment? No questions? Okay. Now there are some other parts of this homework assignment that is really kind of important, because remember what I said, this is setting up the infrastructure for all of your other homework assignments. So that's why there's this section here that says in all future homework assignments, homework assignments, unless otherwise stated, these are the criteria for me to even grade your homework assignment. The first thing is make sure you download the document from Moodle and then use that document as your homework. Okay. Some people click on the link instead of right click and then save the file. And what that does is, depending on your browser and your operating system, it might open the document, but in a read-only mode. So that means you cannot make any changes to that document. So some people say, oh, okay, I'll just open up another new document and then copy and paste the content. Do not do that, okay? Make sure you just use the file that you download from the description and use that file for your homework assignment. Do not copy and paste. When you open the file, make sure that you use Libreoffice or OpenOffice to open the document. Do not use Microsoft Office for that purpose. Make sure that your name is reflected in the author part of the document, or at least as the author who last modified the document. Let me show you what I mean by that. I will go back and reopen the file that I edited a little bit earlier. And you want to make sure that when you click File, Properties, that it will show your name as the author who modified the document. It will always show that I am the one who created it. That's fine, okay? But you want your name as the one who modified the document. For those of you who are kind of curious why I want you to use only LibreOffice or OpenOffice to do your homework, you can also do this. You can go to Edit, you can go to, what is it, Changes, and you can click Accept or Reject. And this is a documentation, it's a log of how you modified the document. And that's the reason why I need you to use LibreOffice or OpenOffice, because when you use Microsoft Office to open the file and then save it, this information will be gone. Okay, and I need this information because I want to kind of collect some information about how long it takes for people to do the homework assignment, and also do they do it in one single session or do they break it up into multiple sessions and stuff like that. I'm hoping that no one sees this as an invasion of privacy, because it really is not. Okay, there's no webcam taking a picture of you while you're doing your homework and drinking at the same time. Okay, that I know of. Yes, yes. There's no little picture, little picture of you. Oh man, this is hard. It just records the time and what changes you make to the document at that time. That's all that it is recording. Okay, does anyone have any objection to this kind of logging with your homework? Nope? Okay. Now, this also means that I can tell when someone is copying and pasting, right? Because I will see, with one single timestamp, the entire document got changed.
Quick typer.
Very, very, very quick typer, yes. But in many ways it's helpful too, because I can also tell when people go back and change certain cells, okay? And that tells me what concepts are difficult, because when people go back and change something, that usually tells me that it's a difficult concept when people are they come up with one version of the answer, and then they go like, maybe that's not right. Let me go back and see if it's something else. Okay. So that's something that I need to see, when you turn in your homework assignment. And you can always double check and make sure it is here as well before you turn it in. So are there any questions? So make sure you don't turn on or turn off the track changes in the settings. Just leave it the way it is, and it's going to be okay. Documents that do not meet these requirements will not be graded. Okay. So that's why I want you guys to get into the habit of making sure that your document is prepared for grading. Right. How long would it take you to finish this homework assignment?
Couple minutes.
A week?
Depends on how
168 hours? That's how much time you have in a week, in number of hours. So I think it's okay to make this due in a week. Any objection to that? Anyone needs more time?
thumb drive's not that.
Now, how do you know the due date of a homework assignment?
Shouldn't say.
Yeah, it says right there. I think I have to go back to the previous screen, but it does show in the homework assignment. Yep.
Would we ever need to print something off Libro? Would we ever need to print something?
It's up to you whether you want to print out something, but everything that I need for grading purposes, for homework, is all on Moodle.
Okay.
Your exams, first, second, and final exams will be on paper. But I will give you the paper. You don't have to, print out anything. Yep. So when you look at the homework assignment, it will tell you when it's due. So in this case, it's due next Thursday, right before the class. Because I don't want someone to be late for class because they're doing the homework assignment. So, and it also tells you how much time you have left to do the homework assignment. You have 6 days and 23 hours remaining to do the homework assignment. It tells you when you last modified or turned in something for this homework assignment. And for anything that has file submitted, it also gives you a link so you can download the document back and double check for yourself whether it is in the right format or not. So are there any questions about how to turn in homework assignments? Yep.
Should we keep it the same name that you
Doesn't
have
matter.
set?
It does not matter because when you turn it in, you already signed in as you. So as far as I'm concerned, the file name is irrelevant because I know exactly who turned in that file. Okay. Okay. Any other questions? No other questions? All right. If there are no other questions, we'll continue with the course content in topic 1. Topic 1 is really general stuff. There's nothing really exciting in topic 1, but I have to go over that just to establish a context for this entire class. So the context is who is a developer? What does a developer do? And what are algorithms? Those are the two main questions that I want to answer with this particular slide. And as you can see, it was written in 2006. In 2006, was the iPhone out? What about Android? Okay. Does that kind of give you an idea of how fast things are changing?
Yeah.
Maybe. But 2006 and now, there are only 8 years. 8 years have passed. If you look at anything else, okay, I don't even care what else you're looking at. If you look at cars, okay, you look at a car that was manufactured in 2006, and you look at a car that's manufactured today in 2014, you don't see nearly as much change. Okay, maybe Bluetooth, is now standard, whereas back then it's like a novelty. But when you look at software and software development, a lot has changed, during that time. So what we'll do is, I'm gonna click on the slides, but I'm not gonna read entirely from this because it will be extremely, extremely boring. Okay. So what we'll do instead is I'm just using this as a clue as to what I need to talk about, but I will talk about it in some other formats. So what I'll do is I'm going to click. What do you think was the first electronic computer? Mac?
Isn't it Commodore or something?
Oh, wait,
Commodore?
No, before that.
Oh, way before that.
Oh, yeah.
It was like 1950s or something.
It's before
Wasn't
that.
it the Switch?
Started with the E.
Right, yeah.
It's before that. I think it's called the ENIAC, right?
Yeah.
Yeah. Okay. So what you want to do, what I'm not going to do is to look at ENIAC. Okay, pretty sure that's a spell typo here. No, I did not. It's not a typo. It's troubling when I can remember names like that. Okay, so I'm not going to read this whole thing. Okay. Well, that's not even the first one. I think that's another one. Let's see. Colossus, that's it. Colossus. Computer. There we go. Okay, that's the one that I wanted to point out. Okay, come on. Okay, there we go. Okay, I'm not going to read the whole thing, so it's okay not to be able to read the text here. The Colossus computers, okay, there were actually 10 of them by the end of World War II. The primary function of these computers is to crack the encryption of German transmission at the end of World War II. Okay, the British were able to do it by hand, okay, manually, for the first part of the war. But at the end of the war, the German added one more disk to their encryption machine, called the Enigma. And that one additional disk made the problem so much harder that it would not be feasible to crack encryption by hand. Now, encryption cracking is always possible. The only question is, how long does it take to crack the encryption? In the case of military application, if you can crack the encryption 2 years after the transmission, well, it's useless at that point because everything is already over. So that's why at the end of World War II, the Colossus computers were invented in order to do the encryption automatically using computers. And the story was these computers are so fast at decrypting the encryption, sometimes the British were able to read the actual message before the Germans could. Because the Germans, on the other hand, do not have computers like this. So when they receive an encrypted transmission, they actually have to manually copy the text from the radio onto the Enigma machine, which also do the decryption, in order to find out what is the actual content of the message. The British, on the other hand, had these computers, right? So they were able to read the message before the Germans, could, and in many ways, it's really kind of funny in a way, right? And sometimes, the Germans would also have a reception error, and they would go back and say, please retransmit, and the British were just giggling in the room. It's like, yeah, we could read that, you could not. But these were considered the first electronic digital computers. So if you just kind of bump up the font size here, it says right here, Colossus was the world's first electronic digital computer that was at all programmable. Okay, because whether it's programmable is a big deal. Because if the computer is not programmable, then it doesn't need programmers, doesn't need software engineers. We don't have to take classes like this. But this one was programmable. That was at the end of World War II. So when you look at the time frame, the first one was manufactured in 1943. Mark II, which was the last revision of it, was released in 1944. It was discontinued in 1945 at the end of the war. How much time, how many years have passed since then? Well, today is 2014, so 70 years, right? About 70. Okay, and that's why we see these numbers here. So in 70 years, okay, let's call it 72 because I want something that's divisible by 3. So let's call it 72 years. This number is calculating how many 18 months have passed since that time. Okay? Well, it's basically dividing it by 1.5, but I'm using a fraction to do the calculation. So we have 48 periods of 18 months since the end of World War II. Is that okay so far? Okay? It's an approximation. I know I'm off by 2 years or so. It's okay. Okay, so the question is, if Moore's law has been right the entire time, what would be the performance difference between one of these Colossus computers versus a computer that we can purchase for the same amount of money today? What type of difference are we talking about here? Moore's law says performance, computer resources doubles every 18 months. And that's why I want to calculate the number of 18 months in 72 years. It's 48. So that means the performance of a computer of the same price. Now remember, you have to adjust for inflation and whatnot. So if that computer costed, let's say, $200,000 back then, it would be a lot more than $200,000 today because you have to adjust for inflation. So we are talking about 2 to the power of 48. That's the factor that we are looking at. Okay? If that computer can perform one operation per time unit, I don't care what time unit you want to use, nanosecond, milliseconds, whatever, a computer today for exactly the same price will be able to do 2 to the power of 48 number of operations in the same amount of time. And this is really just an approximation so that I can show the number in base 10. The way I do this is using this approximation here. 2 to the power of 10 is 1024 exactly, which I would just call, well, it's close enough to 1,000. Okay, we're off by 2% or so, but for approximation purposes, it's okay. So I want to find out, first of all, how many 2 to the power of 10s do we have in 2 to the power of 48? Okay, for those of you who know your algebra and your exponents, well, this is the way we do it. 2 to the power of 10, and then the whole thing to the power of 4 will take care of 2 to the power of 40. Then we have 2 to the power of 8 remaining. So when we do the approximation, we say 2 to the power of 10 is about 1,000. So the whole thing to the power of 4, and then 2 to the power of 8 is 256. So we are looking at this factor here, 256, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. That is the factor that we are looking at. Okay. Are there any questions about how I came up with this number? Does it look kind of realistic to you? Absolutely. Because we are talking about vacuum tubes in these original computers. Okay? And vacuum tubes are very slow. They're very slow devices. All right. This tells me that hardware has seen a lot of changes over the past 70 years. Would you agree?
Yeah.
I would say out of all the technologies that we use, these days, computing technology is one of those weird technologies that have, changed the most, during the past 70 years. When was the jet engine invented?
In the 44.
Was it the end of World War I?
Yeah, we were around.
Okay, that's World War II.
World War II.
Yeah, World War II. Obviously, those engines were primitive by today's standard. Do you expect this kind of performance difference between a jet engine back then versus a top of the line, super high-end jet engine today? No, you may be looking at what, 4 times, 10 times maybe in terms of performance. Nothing like this. Internal combustion. Okay, Ford, Model F, right? Model T. Model T. Do you expect this kind of performance difference between the engine back then versus now? We're still looking at a good, number of, advances, since, Model T, but not quite, using this kind of number. Now, why is that significant? Why is this, all by itself is significant? And just kind of think about, if Moore's law continued to double performance every 18 months, what is it leading us? Go ahead.
To more advanced technology that we didn't think would happen.
Mm-hmm.
Infinite possibilities.
A lot of different possibilities.
Can't even imagine.
Go ahead. Okay. A lot of possibilities. Think about this, okay? Now, let's say, nobody invented the jet engine, okay? So we are all still flying, propeller airplanes, okay? And we don't even bother with, efficient, propeller engines, so we're all flying, biplanes. All right? Okay, well, we have biplanes. But let's say, computer technology, it's still, advancing the pace that we saw earlier, okay? Back 70 years ago, it would not be possible to have autonomous drones, right? Because even if we have the computing capability, no biplane would be able to carry a computer that big to fly with it. Does it make any sense?
Yeah.
If aviation technology has not advanced at all since the biplane time, but computing technology has kept up, at its current pace, we would still be able to automate a biplane and have it to fly itself. I mean, that is, what computing technology can do. It can change. It's a game changer. It's a really, really significant game changer. Right. So after we talk about how digital stuff, digital computers, the hardware has changed, over the past 70 years, it's time to talk about, but what exactly is software? But has that changed at all? Well, right here you see, the statement right here already. The fundamental concepts of programming actually has not changed. When you look at the software side of things, in terms of computers, it hasn't changed. Now, let's go back to this slide here because I want to find this guy's name, Alan Turing. It should have its own link here, but it's not. Okay, this is Alan Turing. He is considered the father of computer science. Okay, he came up with all the computational theories related to computers. And those theories are still basically the stuff that I study and the stuff that you will study when you go through a computer science course. In other words, the theory of computation has not changed over these past 70 years. And I think it will not change until we have quantum computers, because quantum computers will significantly change the way we look at computational machines. Right. what exactly is software without reading this?
The instructions that allow the hardware to do what it is capable of.
The specification of how the hardware should perform operations. Okay, that's software. And most computers are programmable, which means those instructions can change. Okay, you can download or get a new computer program into a computer, and then that changes the instruction. The best way to look at software is the operation manual to tell the processor how to perform various tasks. What do you think? Well, since I have it written here, I'll just point out. At the lowest level, even your i3, i5, i7 processors, top of the end processors, can only perform very simple operations like addition, subtraction, comparison, multiplication, maybe, division, maybe, because those two can be implemented only using addition and subtraction. Okay. Well, if you only have building blocks that small, that means you will need a lot of instructions to make computers do all the fantastic things that they can do. Computers and software is also everywhere. When I wrote this is before the app days, so I was using some other things to demonstrate. I guess cell phones even back then are already basically computers. But
Your
not.
next sentence after that's kind of funny. Your next sentence after that's kind of funny.
It does not necessarily have a large screen or a regular keyboard, but it has a processor and many other components not that are commonly found on a computer. And the cell phone have software as well. Well, these days we don't have cell phones, right? We have computers pretending to be cell phones. Cell phone or the phone part is an app. It's like, oh, okay, I got this computer that is small and it has an app that will turn it into a phone. That's basically what it is. Okay, the next paragraph talks about an inexpensive car, EconoBox. It already has multiple computers. Okay, you have one to do engine control. Okay, to basically monitor the NOx sensor, the oxygen sensors, and whatnot, and it controls the timing of the ignition. It controls the posing of the fuel injectors and so on and so forth. And that's its only job, okay? It's engine control. Anti-lock brakes has its own computer. Your radios and temperature, climate control has its own processor. So when you look at a modern car, I would not be surprised to find 7 to 10 processors easily. Okay, easily. The instrument panel has its own computer, and the whole thing, all of these computers are networked inside the car. They have their own networking protocol called CAN, C-A-N, which stands for Controller Area Network. Inexpensive toys, Furbies, have processors and software. Okay, and I heard from the previous class that Furbies are having a comeback. Is that true?
They're pretty expensive.
That would be
you would know about as much as I would.
They're on the market, but they didn't make it as big as they were at the beginning.
That's because they did not turn it into a Furby app. Now, if you have a Furby app, that would be a different story.
Maybe we can make them a little less creepy.
Yep. Okay. So, in summary, there are computers everywhere, from inexpensive toys and gadgets all the way to high-tech, space vehicles and military aircrafts and so on and so forth. So the question that I want to present to you is, how inexpensive is a processor? And I mean the whole thing, not just the processor, but also the RAM, the ROM, everything else, except for the electricity to get it to work.
Extremely cheap.
How much? Order of magnitude.
Raspberry Pi for like
20, 30 bucks? Okay. Anyone want to go lower? How about 50 cents?
Yeah, just thinking less than a $5 bill.
50 cents, okay? For 50 cents, assuming you order like 5,000 at a time, for 50 cents, you can get a processor. If you look at the chip itself, the packaging, it's about the size, half the size of your the fingernail of your pinky. Okay.
Wow.
And that's really just the size of the package. It's not the size of the chip. The size of the chip is much smaller than that. Okay, and it will only cost you 50 cents. Now, it's not a Pentium processor. It cannot do a lot of stuff. In fact, it only has space for 256 instructions written in assembly language. Okay, but it is still a processor. It's self-contained. You just give it 5 volts and ground, and it works. It's programmable. Okay, what can we do with something like that? I mean, if they are selling, it must mean that they are used for certain things, right? Make coffee. Security, you can monitor the closure of a window easily. I mean, it's only 50 cents, right? Go ahead.
The toys, like kids meal and things like that.
Yep. You can certainly put it into toys. In fact, in those situations, I would say the circuit board itself is going to be more costly than the processor itself. Because circuit board actually is not inexpensive to manufacture because of the material involved in the circuit board, in the PCB. What if you want to kind of automate something? Let's say you want your backpack to warn you when someone is approaching you from behind at a high speed. Would it be doable today?
Just gotta get a sensor.
You need a sensor, you need a processor, you need something to warn you, like a beeper. Yeah, it's definitely doable. And the least expensive part of the implementation is the processor. The sensor is going to cost you, I would say, $5 to $10 easily. The buzzer will cost you $1 or $2. Okay.
Unless you can hook it up with your phone somehow, maybe make an app that.
Yeah, but for something that critical, I would not go through the phone first. It'll just give you a warning. Beep beep beep
Yeah,
beep.
if you leave your backpack alone.
It's like it's like when you watch Top Gun. Top Gun is probably way too old for some of you here. When you have a missile coming after you, you have that warning beep 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 beep, beep like that. So you can have your backpack to give you the same sound when someone is about to jump you. And you can even have automated defense too. Your backpack can do something actively to
Throw your lunch.
like pepper spray. Pepper spray actuator, pointing backwards.
Walking right behind you.
No one walk behind that guy.
Right in the face.
Yeah, well, there'll be some legal,
Ramifications.
issues, with that approach, but it's doable. It is definitely doable with today's technology. For $20, you can have your, anti.
Stranger danger.
Yeah. Yep. I'm not kidding. I mean, it's really that inexpensive to have a processor. Computer is no longer the expensive part of anything. Have I talked about torque wrenches with computers inside?
Not in this class.
Not in this class. It has been reality for years. Okay, Snap-on, which is a high-end tool manufacturer, they have a torque wrench that has a display. Okay, when you think about a torque wrench, you just say, well, we dial in the amount of torque, and then we just do it until we hear a click, right? That's how a torque wrench works. But now you have programmable torque wrenches. So you have a user interface, and you can program in the amount of torque that you want to set up to. So when the torque wrench is experiencing that much torque, it will beep you. So you don't have to turn the dial and do all the mechanical stuff anymore. It's really just a user interface. What would be the next revision of this technology? Bluetooth, right? You use your phone, you pair it with your torque wrench, and then you go through an app on your phone. You can specify the torque. Now, you don't even have to specify the torque, depending on the application, because what you can do is you can select the vehicle, okay, based on make, model year, and the
Already has the preset
the
for it.
destination of the car. You can specify the tire. It will automatically look up and program the torque wrench for the right amount of torque for the, let's say the lugs, okay, the wheel lugs, okay. So you don't have to look up anything. There's no chance you can make a mistake unless you specify the wrong car, right? Well, how do we prevent us from specifying the wrong car? You walk up to the windshield, you take a picture of the VIN. Is it science fiction? It's entirely doable.
We have the technology.
We have the technology today, right now. We have the technology to do it. Okay? And that really, on the side, it really has implications to many other occupations as well. Okay? If you kind of think back and just, if you have watched movies, you can kind of think about that too. Let's say 20 years ago, what do you think an automotive mechanic would do? What is the typical image that you will think of when you think about someone who fixes cars?
Changing oil a lot.
Changing oil, okay.
Opening the hood.
Opening the hood. What else? Jacking up the car, looking at leasing components and stuff like that, right? So today, let's say your car has a check engine light on, okay, and you put a car into a garage. If the first thing the mechanic does is to open up the hood, what do? You say, okay, thank you so much. I'm driving my car away, or towing it away. Exactly. That should be the first thing you do is to check the computer and see what the computer has to do. A mechanic that I personally use has, I would say, around 20 laptop computers. Each one is loaded with the manufacturer-specific software and a dongle to go along with it to do diagnostics. 20 computers. I would say his electronic tools are now starting to about equal his mechanical tools. And that's computers doing its job. I mean, it's really changing, how we do things, even not when it's not supposed to be computer related. Right. So let me see when I will talk about algorithms, because I want to kind of skip around a little bit and talk about algorithms too. Okay. An algorithm is essentially a method to complete a particular task. So if you want to look up, what an algorithm is, you can just look it up in Google, and the first link is, to Wikipedia. And Wikipedia, it's really a long document. I would not print this out and put it into a binder, because all I really want to do is to point out the first paragraph, right there. In mathematics and computer science, now there are people who would argue and say there's no mathematics and computer science because computer science should be a branch of mathematics. It's just like calculus is mathematics, right? And some people believe that computer science should be mathematics. Now we'll come back to this topic a little bit later. An algorithm is a step-by-step procedure for calculations. Algorithms are used for calculations. Now, calculation we kind of understand, okay? One of the earliest applications of computers is to compute the trajectory of projectiles, okay? Like, shells from a cannon. Data processing, we know that stuff too. The government uses a lot of data processing stuff. But I think increasingly, the third item, automated reasoning, is also becoming more and more common. What type of automated reasoning are we talking about here? Can someone give me an example of a computer that can do certain types of automated reasoning? Yep.
Autopilot?
Autopilot, okay? Autopilot can do a certain degree of automated reasoning, but for the most part, it's kind of mechanical, quote unquote mechanical, because how to fly an airplane is a mechanical kind of process. The autopilot, doesn't have to make a whole lot of decision making, right? Yep. Go ahead. Siri, okay, Siri is definitely falling into the category of automated reasoning. Google cars, Street View cars. Okay. Does anyone know what is a Google Street View car?
Yeah.
Okay. What is so special about that car, other than it has got a funky looking camera rig on it?
So the only person in the car, if there is somebody in it, is not sitting behind the driver's seat. Self-automated.
It's fully automated. A car that drives itself. Okay? Has anyone confirmed that? Has anyone seen a Google car up front in person?
Yeah.
I have. Okay, did you see the car driving itself? The driver, the person in the car is not doing anything.
Passenger seat. It's kind of
Yep.
creepy.
Yeah, the person is usually on the passenger seat with a laptop.
Yeah.
Yep. And that's your
I was looking
experience
at
too?
the camera on top because when it drove by.
Yep.
I was standing out there in front of my house and it drove by.
Oh.
It was doing street view for the Google Maps.
You can wave to it, they will blur your face, so you don't have to worry about your face showing up on Street View, but it's funny. I was driving on 101 in the Bay Area once, and there was a Prius, next to me, and I turned and looked, and it had the camera rig on it, so I knew it was a Google car, and then I just looked, it was nighttime already. I was able to see the person inside the car because of the light from the computer screen. That person was, just doing things, on the computer, and the car was driving itself. Is that science fiction? No.
What's the price on one of those right now?
Sorry?
What's the price tag?
The price tag, I do not know, but there are manufacturers, Tesla included, to release passenger cars that we can purchase off the lot by year 2020 to have the same kind of capability.
Pretty cool.
I think it's
If you
cool.
can't- if you're not good at driving, you can get one of those to drive you there, just in front
Yep.
of the destination.
Yep. Yep, the person-
I
the-
still wouldn't trust it though, just because it just seems like it could.
You'd be nervous also,
Yeah.
but it's better than walking.
Well, but driving a regular car is not any quote unquote safer, because some cars are now steered by wire, throttle by wire, has been the standard for a long time. So there's no mechanical linkages between your quote unquote user interface in the car to the actual mechanism anymore. Yep, go ahead.
I forgot.
Oh, okay.
I would just be kind of scared because what if the car just randomly circuited, and what would you do then? It just starts going out of control.
I
Those
think the
people getting
chances
really
of
hurt.
that happening is less than the chance of you getting hit by someone who is driving under the influence.
Yeah, I drive for a
It's
living
definitely
right now.
happened more often.
Mm-hmm.
I trust a computer over a person on the road any
Yep.
day.
Yep. Because Google is already
What about
doing all the
off-road?
testing for us. Okay. For the entire history of Google cars being automated, the only accidents that it was involved in were all human errors,
Somebody else hitting them.
or the person was intervening, backing up the car and made a mistake. Yep.
If they make the cars automated like with computers, is it possible they could hack the car and control it?
Absolutely.
Like
Absolutely. If it is computer based, okay. Well, that's a very good point because it gets back to computers being programmable, right? If something is not programmable, there's no way to hack it because you cannot alter the way it does things. So it is only because they are programmable that they are hackable. Well, obviously you have to have a way to connect to it too before you can make changes to it. Yep. But I think you can almost guarantee that future cars will have almost constant communication in some form, in some way, with some kind of server. I mean, that's almost guaranteed. They want to collect data of every kind out of your driving habit. Yeah.
Is there a manual override for Google cars just in case?
I do not know. I don't know.
Probably is.
Yep.
As a safety concern, part of
As
the,
a safety-
one of the things that allowed them to be able to do it. More than
Yeah.
likely.
Like a fail-safe,
Yeah.
mechanism. Yep.
In case it gets a virus or something like that.
Yep. Like a wrong update.
Wrong update.
Yep. Surface Pack is being applied.
Well, Ford-
Okay. Yep.
Ford cars can already park themselves.
They can. The Lexus can do. Certain models of Lexus can also park themselves. But we are talking about cars that can drive themselves.
Well, yeah, I know, but
Yeah.
I mean,
It's a
it's
start.
already.
It's already, the cogs are already in
It's in the
motion.
go already.
Yes, definitely. And as I said, by year 2020, some manufacturers are planning to have self-driving cars, in a lot, in a dealer's lot, so that we can purchase cars like that. And it makes a lot of sense too. I mean, if you have kids or you have elderly people, it just makes a lot of sense, so that the car can just drive themselves. Some of us are old enough to remember, a science fiction, series back in the days called
Knight Rider.
Knight Rider.
Oh, yeah.
Yep. and the car, makes a swishing sound, has an eye, swooping eye, kind of like the Cylon one, in Galactica, and the guy, what's his name?
Michael Knight. Michael Knight.
Yep, Michael Knight can talk to the phone, can talk on his watch, to the car, and say, "Kid, pick me up around the corner," and make it pronto, right? You can actually do it now. Okay, Google cars can basically do it. Okay, because we don't even need to talk to the watch because we have Bluetooth headsets, right? You just make one click and say attention vehicle, and then you just say pick me up here. How does it know where you are? Your phone has GPS.
Yeah.
Right? Your car can even tell you, I cannot park where you are. Can you proceed and walk 20 feet to da 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 da? Right? It's all happening. Technology, reality is now progressing almost faster than science fiction in some cases.
We still need hoverboards by 2015, though. We still need hoverboards by 2015.
Yeah, we're running out of time on that.
Yeah, we're getting close.
Getting close to what?
Hoverboards in 2015.
Back to the Future. Next
Yeah.
year is the year Marty McFly goes to the future.
Oh. Well, I think I want my car to drive itself first before it can fly.
Yeah.
Then you can learn to fly itself.
Well, since we're talking about flying stuff that is automated, we have to point out the X-47.
The drones.
Yeah, the drone. But the X-47 is significant in a very important way.
The stealth drone.
It's the stealth drone, but it's not the stealth part that I want to point out. It is the autonomous part that I want to point out. Because up to this point, when people think of drones, they think of what? They think of a really big, fancy remote control airplane. Okay, somebody halfway around the world will be flying it remotely. Yep, go ahead.
It was funny with his comment about someone hacking the car because I believe it was Iraq hacked one of our X-47s and landed it.
Already?
Refused to give it back to the United States.
Well, just making it land somewhere else is not the worst kind of hacking when these things are concerned.
But now they can dismantle it and study it.
Maybe it was meant to be.
Yeah, it's already disappeared.
Maybe it already had hack software on the X-47 intended to be hacked so that the software will back hack whoever is hacking it, right?
Has a bomb in it right now waiting to blow up.
Well, they're supposed to have bombs in the control system to blow themselves up, in case they are not, in case they will be captured. Now, think about this, okay? These things are automated, okay? So, ideally speaking, from the commander's perspective, if you want to neutralize, some, plants or some factories, it's drag and drop. On the screen, you just drag and drop an icon, and then minutes later, that target will be gone.
Never exists.
Okay? Ideally speaking. Now, if these things can be hacked, okay, it presents, I would say a serious problem. Okay? Now, do people defect, do people, defect to another country?
Yeah.
Sure they do. I mean, during the Cold War, we have, numerous cases of, pilots, defecting with their top, top secret, high-end, airplanes. Can you convince 500 pilots to defect all at the same time?
No.
Probably not. Okay. But once these things are hacked and they're all identical, do you think they can program all 500 to be turning around at the same time?
No.
Okay. It is entirely possible, and they'll be carrying bombs and whatnot too at the time. So it's not like you just lost an airplane. The airplane is coming back to bomb wherever it was taking off from. So I would say these are very, very serious topics. When these things are automated, I think we have serious concerns. When it comes to security. How many people here are interested in computer security as an occupation, as a career? Well, that would be a good direction to go because there can only be an increasing demand of computer security personnel. There's no turning back anymore.
We've gone too far.
Well, it's not just us too, because it is an adversarial type of situation.
As a global community.
It's global as well. The Earth is flat as far as computer security is concerned. Okay, When you look at technology, this is another thing about computer and computer technology that is really interesting. When you look at aircraft technology, okay, the Earth is definitely not flat. Okay, back when the Blackbird, what is the code name of the SR-71 was top secret and whatnot, they could have given the plan to the Russians, and the Russians would not be able to make it because it requires machining skills, techniques, and equipment that all of the other countries do not have. So they can have the plan, they can look at it, they can make something that resembles the airplane out of steel and some other material, but it would not have the same performance. So it's useless, right? But when it comes to computer security, what do people need in order to hack? Internet and a computer, right? Do you really need high-end super duper computers to do hacking?
Not really.
Exactly. And you can do it halfway around the world too. There's no proximity limit. You don't need expensive equipment, machines and whatnot to start hacking. So I think computers, in that sense, also changes the way we look at conflicts. Okay, how one country can try to control another country, and so on. Well, that means more jobs for these people, don't you think? How many people know what is the name of the virus that targets nuclear plants only? How can I forget something like that, but I can remember the name of the drone? It's well, I can always
Google it.
Google it.
Google has everything.
Nuclear
Iris.
plant virus. That's all I need.
Google has everything.
Stuxnet, that's it. Okay, this is a virus, okay? And you think about a virus like, well, it's gonna hack my computer, it will make my computer join a botnet, and my computer will be a part of a botnet and launch DDoS attack on some unfortunate bank website and whatnot. Well, this is not one of those viruses. This one is a computer worm designed to infect and stop the production of, or the refinement process of uranium. That's its job. Okay? Now, that is not an easy task. Why is it not an easy task? Okay, you have to kind of read the rest to really realize how complicated this kind of software is. It has to do with a nuclear plant or any factory. They run on what we call industrial controllers, okay? In other words, we have non-PCs, non-Windows machines that are actually controlling the equipment inside the plant, okay? So that means infecting a PC, you can infect the PC all you want. All you're doing is changing the user interface computer. So you can mess up the user interface. In fact, you can rip that computer off of the network, smash it, and the nuclear plant will continue to operate like it's normal. No problem. Because the PCs are nothing more than just terminals. Okay? So that means in order for a virus to stop the process of refining uranium, it cannot just infect the PC, because the PC is just a dumb terminal. It has to contain a payload that can go out and infect the individual industrial controllers. So not only do you have to find a flaw, a security flaw with a PC running Windows, you also have to find a way to reprogram those other things. Now this particular virus was not programmed to shut down a nuclear plant, like shut down.
That was easy.
It's designed to change the speed of the centrifuge in a way that it will just wear itself out. In other words, they will just die prematurely. And unless you look really closely at why they die, you would not be able to find out that it was because of the infection of a virus. So it was definitely I would say this is a very high-end type of malware. It's not one of those things where you just infect a computer, get a backdoor so you can remote control it later on. This thing is definitely purpose built to stop the refinement of uranium in a way that is difficult to discover later on. Okay, and where does it point to? Not politically, occupationally speaking. It points all the way back to these people, developers and computer scientists. Does it make sense? Because somebody has to design that thing, right? And it's these people, who help, design and implement, programs of all kinds. You look at Watson, you look at the X47, you look at the Google cars, you look at Stuxnet. One thing they share in common is that they need these people. Okay. So now we have, section. Well, we have 5 more minutes, so I'm gonna do just a little bit more of this, and then I'll point to. I forgot. I forgot to pass it because I was talking about things that are just kind of fun. Okay, so here's the roll sheet for today. Yep. So I'm hoping that 5 minutes will be enough. So try to do it as quickly as you can. Okay. Electrical and computer engineers are the ones responsible for the research, design, and implementation of the hardware components of a computer. How many people here are planning to become an electrical or computer engineer? Okay, so we do have a few people focusing on the hardware side of computers. The software side has basically 2 types of people. One type of people are called developers, and the other type of people are called computer scientists. What do you think would be the differences between the computer scientist and the developer?
Like theory and actually practice.
Yep, that's basically it. The computer scientist will be focusing on the theories and the research of certain topics. Developers, on the other hand, are like contractors. Okay, you have to tell them what you're trying to build, what kind of software you're trying to write, and they can handle the details of getting it done. Okay? So that's developers and computer scientists. So I'm going to stop the discussion here, but I do want to point out one thing, just in case someone in this class gets bored later on because well, we're doing all the pseudocode and tracing all the code by hand, but I want to apply what I have learned so far to actually do something. Well, how many people are thinking maybe I want to do my own mobile app? I want to write an app for my phone, my tablet, and whatnot. Okay. Well, as it turns out, there's a quick and easy way to do it now. It's called appinventor.mit.edu. Sorry?
They have the second one out now.
They have version 2 now, right? Mm-hmm. Okay, this is their website. It's appinventor, one word, .mit.edu. It's really cool because you don't even have to learn C++ or Java or anything like that. No syntax whatsoever to start to program. And the program runs on your mobile device. In order to sign in, to start, you have to have a Google account. Your school account counts as a Google account as well, so that actually will work awesome. Okay, so after I sign in, I say, okay, use Google to authenticate into it. Okay, and this is my only project here. This part designs the user interface, and it's drag and drop. Okay, in other words, you say, well, I want to have another button. Okay, you just drag a button here. I want another checkbox. You drag the checkbox into here. And this is all done using the browser. You don't have to install anything other than a browser at this point. Okay? And so, okay, great, I can design the user interface. But what do I do with the code of my app? How do I specify the logic of this code? Well, from here, you can switch to blocks. Basically, the code, the pseudocode, the code of this program is called a block. So when you switch to blocks, you'll be able to write your programs. Okay? And as the name implies, your algorithms are now specified as blocks. Okay? No syntax needed. Now,
like Scratch.
Yeah, it is related to Scratch. It's basically done by the same group of people. So when you want to do any type of editing, okay, I'm just going to toss this first. Computer is really slow now that I'm running Windows. Come on, I just want to toss something into the trash can. Okay, there we go. Okay, so what you do when you're writing the program is you click, and then you select the kind of block that you want. We have not really talked about, conditional statements and loops and whatnot, but you can just drag a conditional statement here, and then you can. It's really, really slow. I just don't understand. Why is it so slow? Okay, and then you can also specify logic, and or. You can put a conditional statement inside a conditional statement. We'll talk about all of this stuff, in this class. You can make subroutines and so on and so forth. So writing a program is not writing. Okay, it's you spend very little time typing. You spend most of the time dragging and dropping. Okay, you cannot have syntax errors because it doesn't let you have syntax errors. There's no way to specify something structurally incorrect. Okay? But the best part is, it is not a toy interface either. Every single topic that we will talk about in this class, okay, control structure, variables, arrays, subroutines, parameters, local variables, and so on, everything you can actually practice it using App Inventor. So if you have an idea and you want to implement it as an app, and you want to apply what you have learned in this class, I would say on the side, when you have time and the interest, go ahead and use this as a mechanism to kind of help you understand the programming concept and have some additional chances of practicing it. Okay, I just want to point this out early on so that for those of you who want to, everything that we talk about in this class, when we talk about conditional statements, hey, go there and do something with conditional statements. Okay, and that's it for today. I'll see you guys on next Tuesday. Have a nice weekend.
Inventor?
Uh-huh.
I was wondering if you could help me out with the logic.